Tonight, we're going to explore what China found on the dark side of the moon, specifically the strange, silent discoveries made by the U-2 rover as it crawled across the ancient hidden plains of the von Karman crater. This is not something you need to understand all at once. You don't need to remember the technical specifications or the chemical formulas. You can simply listen and allow your thoughts to drift as we follow the slow, steady tracks of a small machine moving through a world that has never known the sound of wind or the touch of rain. The moon's far side has always been a place of total darkness in the human imagination, though it is often flooded with sunlight. It is a land of secrets, a place where time has been frozen for billions of years. As we discuss the things U-2 has uncovered, from translucent beads to mysterious gel-like substances, we will do so with a calm, patient rhythm. The secrets of the moon are not in a hurry to be told, and you are not in a hurry to hear them. To begin, let's start with something familiar. Imagine, if you will, the simple act of looking up. For thousands of years, every human who ever walked the earth, from the ancient astronomers of the East to the sailors navigating the Mediterranean, beheld the exact same lunar face. We saw the man in the moon, the rabbit in the moon, the shadows of the Lunar Maria. It was a comforting, static constant in an ever-changing world. But behind that familiar visage lay a hidden hemisphere, a silent half of a world that remained tucked away, facing the deep cosmos as if in a private meditation. Tonight, we are turning our attention toward that hidden side, moving slowly away from the bright, noisy civilization of our modern world. As we drift toward the von Karman crater, we must leave behind our usual sense of time. On Earth, we measure our lives in minutes, hours, and days that pass with frantic speed. But on the lunar far side, time behaves differently. It is measured in billions of orbits and the slow cooling of ancient basalt. The discoveries we will discuss tonight, the strange reflections in the dust, the echoes beneath the crust, and the geometric shapes on the horizon, are not urgent news flashes. They are quiet revelations, whispered across the vacuum of space. You do not need to concentrate. You do not need to analyze. The mission of the U-2 rover is one of patience and endurance. It moves across a landscape that is both alien and deeply ancient, a place where the history of our solar system is preserved in a pristine, airless state. As the rover's wheels press into the fine, electrostatic dust, they leave behind marks that will outlast cities. If you enjoy these deep explorations in space, consider subscribing or hitting the like button. It really helps the channel grow and allows me to make content like this. When we think about the moon, we often imagine it as a smooth, silver coin. But if you were to stand where U-2 is standing, the ground beneath your feet would feel very different. Imagine a landscape of fine grey ash, not unlike the soot you might find in a cold fireplace. If you stepped on it, your footprint would remain perfectly sharp and clear, perhaps for 1,000,000 years, because there is nothing to wash it away. The rover itself is about the size of a small desk, weighing roughly 140 kilograms. It moves at a pace that is almost meditative, about 200 meters per Earth month. In the time it takes for you to go from one night's sleep to the next, the rover might only travel the length of a single hallway in your home. This slowness is intentional. The environment is harsh, the silence is absolute, and the terrain is unpredictable. This comparison isn't perfect, but it gives us a calm place to begin our exploration of the strange things that wait in the dust. To truly understand this scale, imagine standing in the center of your living room. Look toward the door. For the U2 rover, reaching that door would be a significant journey, a trek requiring careful calculation, solar power management, and several rotations of the Earth. While we are used to vehicles that whisk us across continents in hours, the moon demands a different kind of respect. It demands a surrender to the slow, steady rhythm of celestial mechanics. On Earth, a desk is a stationary object, a place where we sit to work or think. On the moon, this desk-sized machine is a pioneer, a lone wanderer in a desert of shattered glass and ancient stone. It carries with it the curiosity of 1 billion people, yet it moves with the caution of a creature that knows it is entirely alone. If you were to walk alongside the rover, your natural stride would be 1,000 times faster than its top speed. You would find yourself constantly stopping, waiting for the small machine to pivot its wheels or adjust its solar panels to catch the unfiltered glare of the sun. But in that waiting, you would notice things that are usually lost to us. You would notice the way the light hits the grey regolith, casting shadows that are perfectly black because there is no atmosphere to scatter the light. You would notice that the silence isn't just an absence of noise, but a physical presence, a heavy, velvety stillness that has existed since the crust first cooled. This slowness is not a limitation, it is a form of observation. By moving so slowly, the rover becomes a part of the landscape it explores. Consider the weight of the rover, 140 kilograms. On Earth, that is roughly the weight of 2 adult humans. It is substantial, yet manageable. But on the moon, where gravity is only 1/6 as strong as what you are feeling right now in your bed, the rover feels much lighter. It treads softly, its 6 wheels designed to distribute its mass so it doesn't sink into the fine, powdery dust. If you were to pick up a handful of that dust, it would feel lighter than flour, but it would be abrasive, like crushed industrial diamonds. This is because on the moon, there is no wind to round the edges of the soil, no water to smooth the sharp corners of the shattered rock. Everything remains sharp. Everything remains as it was, the moment it was broken. When we think about the distance the rover travels, about 200 meters in a month, we can compare it to the length of 2 soccer fields. Imagine spending 30 days crossing just 2 fields. You would know every blade of grass, every pebble, every dip in the ground. For you two, every centimeter is a data point. Every pebble is a potential window into the moon's volcanic past. This pace allows scientists on Earth to breathe, to think, and to reflect on the images sent back. There is no rush to reach a finish line, because on the moon, there are no finish lines. There is only the expansion of knowledge, 1 millimeter at a time. Think about the dark side, not as a place of shadow, but as a place of isolation. Because the moon is tidally locked to Earth, the far side is forever turned away from our radio towers, our television stations, and our city lights. To communicate with a machine the size of a desk in such a place, we had to station a satellite in a halo orbit, a lonely sentinel watching both worlds. This adds another layer to the human scale. It is like trying to have a conversation with someone on the other side of a massive mountain, using a mirror held up by a friend on a distant hilltop. Every word takes time. Every command is a lesson in patience. As you lie there, drifting towards sleep, Consider how your own rhythm is beginning to match the rover's. Your breathing is slow. Your heart rate is steady. The world outside your room is moving fast, but here, in this moment, you are stationary. You are like the rover during the lunar night, powered down, waiting for the sun to rise over the horizon. The lunar night lasts for 14 Earth days. For 2 weeks, the rover sits in darkness, surviving temperatures that would shatter steel. It does not move. It does not speak. It simply persists. It is a master of the long wait. The terrain the rover traverses is unpredictable, yet it has remained unchanged for millions of years. When the rover encounters a small crater, it is encountering an event that may have happened when dinosaurs still roamed the Earth. To the rover, a crater, the size of a backyard swimming pool, is a major geographical feature. It must navigate the rim, analyze the slope, and ensure its wheels can find purchase in the loose soil. We often think of space exploration in terms of grand leaps, rockets launching, planets spinning, but the reality of U2, too, is a story of small, careful steps. It is a story of a desk-sized explorer finding wonder in a handful of grey dirt. In the time it has taken for us to speak about this human-scale perspective, the rover might have moved only a few inches. In those inches, it has seen things no human eye will ever see in person. It has felt the tug of a gravity we can only imagine. It has basked in a silence we can only dream of. As we move forward into the deeper mysteries of what was actually found in that dust, keep this scale in mind. Remember the small, sturdy desk moving across the vast, ancient continent. Remember that even the greatest discoveries begin with a single, slow, and very quiet step. The environment is harsh, yes. The vacuum would claim us in seconds. The radiation is a constant, invisible rain. But to the rover, this is simply the world. It doesn't find the moon hostile. It finds it logical. The physics are consistent. The rocks are patient. The silence is a medium through which it moves. As we begin to explore the specific things you two found the translucent beads and the deep structures do so with the same calm curiosity. We are not rushing toward a conclusion. We are simply wandering alongside a small friend across a hidden world that is finally beginning to tell its secrets. Allow the image of the rover to stay with you, a small silver and gold box with sturdy wheels, sitting quietly under a sky of infinite stars. It is a tether between our world of noise and the moon's world of stillness. It is a reminder that even in the vastness of the cosmos, things can be understood on a scale we can grasp. A desk, a hallway, a month, a breath. To dwell further on this human connection, think of the rover's physical presence as a familiar object in an unfamiliar room. If you were to walk into your own kitchen or study, you would find objects of similar dimensions, a sturdy trunk, a small filing cabinet, a child's desk. This machine, U2, is not a towering monolith or a sprawling factory. It is a compact messenger. It carries the weight of human ingenuity, but its footprint is no larger than that of a garden cart. When we imagine it rolling across the lunar far side, we shouldn't think of a high-speed chase, but rather the slow, deliberate movement of a gardener tending to a vast, silent plot of land. Every turn of its wheels is a conversation between our world of soft air and the moon's world of hard vacuum. If you were to place your hand on the rover's metallic casing, though you cannot, for the distance is too great, you would feel the thermal blankets that protect its delicate heart. These blankets are like the layers of bedding you might be feeling right now. They are there to keep the internal warmth from leaking away into the hungry dark of space. On Earth, we use blankets to protect ourselves from a drafty window. On the Moon, the rover uses them to survive a drop in temperature that would turn a lake to solid ice in minutes. This is a human-scale solution to a cosmic-scale problem. We take the things we know, insulation, warmth, protection, and we shrink them down to fit this small silver explorer. The pace of the rover, as we have noted, is incredibly slow, but let's look at that slowness through the lens of a human life. If you were to live on the Moon and walk at the rover's pace, a trip to the local grocery store would take you several years. You would see the stars shift their positions slightly in the sky before you reach the end of the block. This encourages a different kind of vision. When you move that slowly, you stop looking at the horizon and start looking at the ground immediately in front of you. You notice the way different grains of sand catch the light. You notice the subtle gradients of grey in a single stone. This is the micro scale of the mission. By being slow, the rover becomes an expert on the mundane, turning the boring dust into a library of history. Think of the sounds the rover makes, or rather, the sounds it would make if there were air to carry them. On Earth, the motors would emit a faint, high-pitched whir, and the wheels would produce a dry, crunching sound as they crushed the volcanic glass of the regolith. It would sound like someone walking on very dry snow in the dead of winter. But because there is no air, that sound only exists as a vibration within the rover's own frame. It is a silent worker. In your room right now, you might hear the faint hum of a refrigerator or the distant rush of wind, but for the rover, the silence is absolute and internal. It is a closed system, a small bubble of human-made vibration in a world that hasn't made a sound in billions of years. The month that we use to measure the rover's progress is also a human construct we've adapted for the Moon. A lunar day, the time between one sunrise and the next, is about 29 Earth days. This means the rover's workday is 2 weeks long, followed by a 2-week night of sleep. Imagine a life where you worked for 14 days straight, never seeing the sunset, and then slept for 14 days straight in total darkness. This rhythm is far removed from our 24-hour cycle, yet it is the pulse of the Moon. U2, too, has adapted to this. It wakes up when the sun hits its panels at a certain angle, like a person waking up when the light hits their pillow. It stretches its robotic arm, checks its systems, and begins its slow crawl once more. When we talk about the dark side, we often fall into the trap of thinking it is a place of perpetual shadow. But in this human-scale perspective, we realize it is simply the other side. It gets just as much sun as the side we see. The difference is the isolation. When U2 is working, it is completely cut off from the direct sight of Earth. If the rover had eyes that could see through the vacuum, it would never see the blue marble of home. It only sees the stars. This creates a psychological distance that we can relate to the feeling of being in a remote cabin, deep in the woods, where the rest of the world feels like a dream or a story you once heard. The rover is the ultimate introvert, finding its purpose in the quiet, away from the constant gaze of its creators. Consider the hallway of your home again. If you were to walk it now, you would pass pictures on the wall, perhaps a rug, a doorway. For the rover, Its hallway is the path between two craters. The pictures are the boulders ejected from the crust during an impact. The rug is a patch of particularly soft regolith that might trap its wheels. Every obstacle is a human-scale challenge. Scientists in Beijing sit in front of monitors, looking at the same rocks the rover sees, debating whether to go left or right around a stone the size of a toaster. This is the intimacy of space exploration. It isn't just about big numbers and vast distances. It's about a group of people trying to steer a small cart around a rock in a distant desert. The breath we mentioned is perhaps the most human scale of all. The rover doesn't breathe, of course. It doesn't need oxygen, but it does respire in terms of energy. It takes in the sun's light and converts it into the electricity that powers its heart. During the day, its energy levels rise and fall with the height of the sun, much like our own energy wax and wane throughout the day. When the sun is high, the rover is active, its sensors hungry for data. As the shadows lengthen, it begins to conserve, preparing for the long, cold fast of the lunar night. This cycle is a biological metaphor for a mechanical reality. It connects the machine to the ancient rhythms of life on Earth, where every creature must find a way to store energy for the dark times. As you lie there, drifting, let the rover be your guide to the smallness of the vast. You don't need to grasp the entire universe. You only need to grasp the next few inches of the path. The moon is a big place, but it is made of small things, glass beads, pebbles, grains of dust. By focusing on the human scale, we make the cosmos a neighborly place. We turn the dark side into a backyard that just happens to be very far away. The rover is sitting there now, a small desk-sized anchor in the grey sand, waiting for the next command, the next sunbeam, the next quiet discovery. The distances are huge, but the steps are small. The time is long, but the moments are precise. The silence is deep, but the presence of the rover is a clear, steady signal. We are tethered to it, not by wires, but by our own curiosity and our shared need to explore the edges of our room. As the light in your own room fades, imagine the light on the moon doing the same. The long shadows are creeping across the von Karman crater, swallowing the tracks, cooling the stones, and bringing us close to another day of slow, patient wandering. You are safe in your bed, and the rover is safe in its crater. You are both part of a scale that makes sense, a scale of desks and hallways and breaths. The universe is immense, but it allows for small things to exist within it. It allows for a machine the size of a desk to uncover secrets that are billions of years old. And it allows for you to let go of the day and find your own stillness in the shadow of the stars. The rover's journey is your journey, slow, steady, quiet. Everything is within reach. Now, let's slowly expand outward. One level beyond the general dust of the surface lies a discovery that astronomers didn't expect: tiny, translucent glass spheres. As U2 moved across the landscape, its cameras caught the glint of something unusual in the grey dirt. They were small beads, some clear as water, others a dark, smoky brown. Scientists understand these spheres by looking at the history of impacts. What we know so far suggests that when a meteorite strikes the moon, the intense heat flash melts the rock instantly, spraying it into the airless sky as liquid droplets. As they fall back down, they cool and harden into perfect tiny glass marbles. On the far side, U2, two found spheres that were unusually large, nearly an inch across. They sit in the dust like lost jewelry from a cosmic event that happened eons ago. But even with everything we've learned, there is still something strange about them. Most glass found on the moon is opaque or filled with bubbles, yet these were oddly clear. It suggests a very specific type of rock was melted, perhaps material from deep within the moon that we rarely get to see. Not because we're missing something urgent, but because the recipe for these glass beads was written in a fire that went out long before humans existed. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. With that in mind, let's move outward once more, to an even larger scale. Now, let's slowly expand outward. One level beyond the general dust of the surface lies a discovery that astronomers didn't expect. Tiny, translucent glass spheres sitting silently in the dirt. To understand the scale of this, imagine walking through a vast, grey desert where every grain of sand is dull and lifeless, and then suddenly seeing the glint of a marble. Not a marble made by human hands, but one forged by the sky itself. As U2 moved across the landscape of the von Karman crater, its panoramic cameras caught these tiny, shimmering anomalies. They were spheres, some the size of a pebble, resting on the surface like droplets of water frozen in time. Scientists understand these spheres by looking at the history of cosmic impacts. On Earth, glass is something we manufacture in hot furnaces, using sand and soda ash. But on the moon, the furnace is the impact of a meteorite. When a rock from deep space strikes the lunar surface at tens of thousands of miles per hour, the energy is so immense that it doesn't just shatter the ground, it liquefies it. For a fraction of a second, the cold lunar rock becomes a spray of molten droplets, tossed high into the airless sky. Because there is no atmosphere to slow them down or distort them, these droplets pull themselves into perfect spheres due to surface tension, cooling as they fall back toward the regolith. What we know so far suggests that most lunar glass is dark, scarred by impurities, or filled with tiny bubbles of trapped gas. It is the debris of a violent event. But these particular spheres were different. They were translucent, almost like amber or a well-worn piece of sea glass found on a beach. When the light of the sun hits them, it doesn't just bounce off, it travels through them. This suggests that the material they were made from was remarkably pure. It wasn't the surface dust that melted, but perhaps a layer of the lunar mantle, kicked up from miles below by a truly massive collision. Imagine the heat required to create such a thing. It is a heat far beyond anything we experience in our daily lives. Yet, as you lie here, that heat is billions of years in the past. The fire has been out for an eternity. The spheres have sat in the same spot, unmoved, while entire mountain ranges rose and fell on Earth. There is a profound stillness in that. To find something so clear in a place so grey is a reminder that the moon is not just a dead rock. It is a repository of ancient, high-energy stories. Astronomers didn't expect the spheres to be this large or this clear. On the near side of the moon, the Apollo astronauts found glass, but it was often microscopic or jagged. Finding these macrospheres on the far side suggests that the geological history of the hidden hemisphere might be even more complex than we imagined. Perhaps the crust is thinner there, or perhaps the impacts were more intense. But we don't need to find the answer tonight. The mystery of the glass beads is a gentle one. It doesn't demand a solution, it only asks for our wonder. Think about the journey of a single sphere. It began as solid rock, deep beneath the surface. It was suddenly turned to liquid, flung into the blackness of space, and then returned to the ground to sit for millions of years. It has watched the Earth change from a molten ball to a blue marble. It has seen the rise of life, the drift of continents, and the first flickering fires of humanity. And now, a small rover from a distant civilization has rolled past it, taking its picture before moving slowly on. The sphere remains. It is a small, translucent witness to the scale of time. As we look at these spheres, we realize that the moon is a landscape of contradictions. It is a place of violent origins and absolute peace. It is a place of shadows and translucent light. The rover, Yutu-2, continues its work, its wheels crunching over millions of these tiny hidden jewels. Each one is a record of a moment when the heavens touch the ground. But for now, that history is resting. The dust is settled. The glass is cold. You might find yourself wondering why it matters that a rock is clear instead of dark. In the grand scheme of the universe, does a translucent bead change our destiny? Perhaps not in a way we can measure with clocks or ledgers, but it changes how we see the moon. It turns a grey desert into a field of hidden treasures. It tells us that even in the most desolate places, there is beauty formed by the most intense pressures. It reminds us that there is always more to see if we move slowly enough to look. The rover's sensors analyze the chemical makeup of the glass, looking for traces of magnesium and iron. The data streams back to Earth, through the relay satellite, into the waiting computers of scientists. They will spend years debating the exact temperature of the impact and the exact depth of the mantle. But for us, the mystery is enough. The image of a clear glass bead sitting in the dark dust of the far side is a focal point for our thoughts. It is a small, quiet anchor in the vastness of the lunar night. Over immense periods of time, even these glass spheres will change. Micrometeorites, the size of dust motes, will slowly pit their surfaces, turning the clear glass back into opaque stone. But that process takes millions of years. For the duration of our lives and the lives of the next 1,000 generations, those beads will remain as they are. They are a bridge between the deep past and the distant future. As we move outward once more, we leave the glass beads behind. They disappear into the grey horizon as the rover crawls toward its next destination. We don't need to take them with us. We don't need to own them or understand them perfectly. We simply acknowledge their presence. They are part of the moon's silent architecture. They are the translucent eyes of the far side, looking out at a universe that is mostly empty, mostly dark, and occasionally brilliantly clear. The slowness of the rover is the slowness of the moon itself. There is no wind to move the beads. There is no water to wash them away. There is only the steady, relentless passage of time and the occasional visit from a curious machine. As you drift further into your own thoughts, let the image of the translucent glass soothe you. It is a symbol of clarity in a world of shadows. It is a reminder that even the hardest rocks can become like water under the right light. The uncertainty of their origin is not a problem to be solved. It is a space to be explored. It is a gap in our knowledge that allows for imagination. Maybe there are entire fields of these spheres waiting in the shadows of the South Pole Aitken Basin. Maybe they are the remnants of a moon that used to have a very different face. Whatever the truth, it is safe in the silence of the far side. It is protected by the distance and the dark. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. We are moving beyond the small beads, beyond the individual craters, and into the larger patterns of the lunar landscape. We are expanding our scale, moving from the microscopic to the global, from the grain of sand to the mountain. With that in mind, let's move outward once more, to an even larger scale. To truly appreciate the translucent glass spheres discovered by the Yutu-2 rover, we must first allow ourselves to shrink down to their level. Imagine you are a microscopic traveler standing on the edge of one of these spheres. To you, this tiny bead of glass is a massive crystal dome, a transparent cathedral rising out of a desert of jagged, grey mountains. Looking through it, the light of the sun is refracted and bent, creating a kaleidoscope of colours that doesn't exist anywhere else on this monochromatic world. This is the magic of scale. What appears as a mere speck of grit to a human eye is, at the right resolution, a masterpiece of cosmic chemistry. Scientists understand these spheres as impact spherules, but that term feels too industrial for something so ethereal. These are the droplets of a world that briefly turn to liquid. Think of a rainstorm on Earth. When a raindrop falls, it is a temporary thing, lasting only until it hits the ground or evaporates. But on the Moon, 4 billion years ago, there was a rain of fire. When a massive asteroid struck the lunar surface, it didn't just move the dirt, it vaporized it. The rock became a gas, then condensed back into liquid droplets as it rose into the cold vacuum. These droplets fell back to the surface, cooling so rapidly that they didn't have time to form crystals. They became glass. The translucency of these beads is what provides the mystery. Usually, lunar glass is dark and dirty because it is mixed with iron and titanium from the surface soil. But these clear spheres suggest they were formed from a source of incredible purity. Imagine digging a well in your backyard and, instead of finding muddy water, you find a vein of liquid diamond. This is what the Yutu-2 rover discovered in the dust of the von Karman crater. It suggests that the impact was so deep and so powerful that it reached down into the lunar mantle, a place where the rocks are different, heavier, and more primitive. This challenges how we think about the quiet moon because it implies that the surface we see is just a thin veil. Beneath the grey dust lies a hidden world of different colours and different textures. The glass beads are messengers from that deep interior. They sat in the dark for eons, buried under layers of later debris, until another, smaller impact excavated them and tossed them back onto the surface for the rover to find. There is a patient logic to this. The moon keeps its secrets in layers, and every so often, it offers a small piece of its heart to those who are patient enough to look. Astronomers didn't expect to find these spheres sitting right on the surface, perfectly preserved. On the near side of the moon, the constant bombardment of solar radiation and micrometeorites usually weathers glass until it becomes pitted and opaque. But these spheres were remarkably fresh. It is as if they were waiting for their portrait to be taken. For the rover, analyzing these beads is like reading a signature. Each sphere's chemical composition is a record of the specific moment it was created, the temperature of the flash, the pressure of the shock wave, and the exact mix of minerals that were melted. But we don't need to read every signature tonight. The beauty of the discovery is enough to sustain us. We can appreciate the what without being burdened by the how. The image of a clear glass marble resting on a bed of grey ash is a perfect metaphor for the human presence on the moon. We are small, fragile, and temporary, but we are capable of reflecting the light of the universe in a way that is clear and focused. The rover moves on, its wheels leaving deep treads in the soft regolith, but the glass spheres remain. They do not roll, they do not break, they simply exist. Consider the time scale of these beads. If a human life is a single day, then these spheres have existed for millions of years. They have watched the Earth grow its first forests. They have watched the first creatures crawl out of the sea. They have watched the rise and fall of every civilization that has ever existed. And through all of that, they didn't change at all. They sat in the same spot, under the same stars, in the same silence. This is the continuity that we find so difficult to grasp on Earth, where everything is constantly in motion. On the moon, the glass spheres are the definition of permanence. As you drift closer to sleep, let the image of the translucent glass soothe you. It is a symbol of clarity. In a world of shadows and uncertainty, the glass represents a moment where things are seen exactly as they are. It is a window into the deep history of our solar system. The rover's cameras have captured that light and sent it back to us across the vacuum so that we can share in that clarity. We are part of the observation. We are part of the discovery. The uncertainty of why these spheres are so clear is not a source of frustration, but a source of wonder. It reminds us that there is always more to learn, even about the things we think we understand. The moon is not a dead world. It is a world that is still speaking to us, if only in a whisper of light, reflected through a tiny bead of glass. We accept the mystery as a gift. It gives us a reason to keep looking up. It gives us a reason to keep sending our small, silver and gold machines into the dark. The scale expansion continues. From the microscopic glass bead, we move to the crater that holds it. The von Karman crater is just one of many, a small dimple on the face of the South Pole Aitken Basin. And that basin is just one part of the lunar far side, and the moon is just one satellite of a single planet. We are moving outward, away from the small and the specific, toward the vast and the general. The glass beads are fading into the background now, becoming part of the texture of the lunar plains. We leave them there, in their silent cathedral of dust. They don't need us to admire them to be significant. They were significant long before we arrived, and they will be significant long after we are gone. They are the translucent eyes of the moon, looking out at a universe that is mostly empty, mostly dark, and occasionally brilliantly clear. We carry that clarity with us as we move into the next phase of our journey, letting the small lessons of the glass guide us toward the larger mysteries of the deep. The rover's wheels continue their rhythmic crunching. The dust settles back into place. The light of the sun continues to refract through the spheres, casting tiny, hidden rainbows across the grey sand. Everything is as it should be. Everything is unfolding naturally. With that in mind, let's move outward once more, to an even larger scale. Beyond the tiny glass beads lies a mystery that initially baffled the mission controllers on Earth. In 2019, inside a small, fresh crater, U2's cameras spotted a substance with a color and luster unlike anything in the surrounding area. The Chinese Space Agency described it as gel-like. a word that felt unsettling on a world that is supposed to be bone dry. To understand this, we have to look at how light reflects off different surfaces. What we know so far suggests that this wasn't actually a liquid or a gel in the way we think of it. Instead, it was likely a breccia, a rock made of fragments of other rocks fused together by the heat of a meteorite. Imagine a piece of dark, shiny sea glass embedded in the dirt, reflecting the sun in a way that looked almost wet in the low-resolution images. What makes this strange is not what it was made of, but where it was found. It sat at the very bottom of a crater, perfectly preserved, like a frozen moment of violence. It challenges how we think about the quiet moon. It reminds us that while the surface looks still, it is occasionally visited by rocks from the deep void. The mystery of exactly how that specific luster formed is an open question, a long-term scientific puzzle. It doesn't imply an answer is coming soon. The gel is just rock, and the rock is just part of the story. With that in mind, let's move outward once more. To understand why this discovery caused such a stir in the quiet control rooms back on Earth, we have to imagine the environment of the von Karman crater. It is a world of matte finishes. Everything is dull, everything is dusty, and everything is grey. Then U-2's cameras panned across the floor of a fresh, small impact site and caught something that shouldn't be there, a glint. Not the sharp, pinpoint glint of a glass bead, but a thick, waxy luster, a patch of material that looked almost like a dark, iridescent pool of liquid. The Chinese mission logs initially described it as gel-like, a term that immediately sparked the human imagination. On a world that has been bone dry for 4 billion years, the idea of a gel or a liquid feels like a whisper of life, or at least a whisper of the impossible. But as we drift closer to this mystery, we find that the truth is perhaps even more fascinating in its geological stillness. Scientists understand this gel not as a biological substance, but as a melt breccia. To visualize this, imagine taking a collection of different colored stones and pebbles, and then subjecting them to a heat so intense that they don't just melt, they fuse into a single, glassy mass. When a meteorite strikes the moon, it creates a momentary pocket of pressure and temperature that rivals the interior of a star. In that instant, the rock is no longer rock. It becomes a fluid, a molten signature of the impact. This particular patch of material was likely formed when a small asteroid hit the moon, melting the local regolith into a dark, shiny glass that cooled rapidly into a smooth, pool-like shape. The luster of this substance is what astronomers didn't expect. It was dark green, almost black, and possessed a glossy finish that stood out against the powdery background. It was as if someone had spilled a bucket of thick, dark resin onto the lunar floor. For the U-2 rover, this was a moment that required great care. The rover cannot simply drive into a crater. It must sit on the edge, extending its spectrometer like a cautious finger, touching the light, reflecting off the surface to read its chemical signature. It found that the gel was rich in plagioclase, a common mineral, but here it was transformed. It had been cooked by the cosmos into something new. What makes this strange is not just the heat, but the stillness. On the surface of Venus, the wind moves slowly, but the air is so heavy it would feel like walking through waist-deep water. It is a world where time seems to have thickened. It takes longer for Venus to rotate once on its axis, than it does for it to orbit the Sunday. A day on Venus is longer than a year on Venus. It is a place where the usual rules of time and light are reversed. And then we reach Earth. We often forget that we are part of this inner circle. We see the Earth as a world unto itself, but in the context of the solar system, we are simply the third rock from the Sunday. We are located in what scientists call the Goldilocks zone, the region where it is not too hot and not too cold for liquid water to exist. This is our human scale anchor. Everything we understand about geology and biology starts here, on this wet, blue sphere. Beyond Earth lies Mars, the final member of the inner circle. Mars is a world of ancient mysteries. It is half the size of Earth, a cold, dry desert that was once, perhaps, a world of rivers and lakes. When we look at the surface of Mars, we see the echoes of a lost era. We see the largest volcano in the solar system, Olympus Mons, which stands 3 times higher than Mount Everest. We see Valles Marineris, a canyon so long it would stretch across the entire United States. Scientists understand Mars by sending robotic explorers to taste its dust and listen to its wind. What we know so far suggests that Mars lost its internal heat and its magnetic shield long ago, allowing the solar wind to slowly strip away its atmosphere. It is a world in a state of deep freeze, a preservation of a time when the inner solar system was a more violent and active place. But even with everything we've learned, there are still things we don't fully understand. We see the seasonal changes in the Martian polar caps, the shifting sands, and the strange traces of methane in the air. We don't know if life ever took hold there, or if it still clings to existence beneath the surface. Not because we're missing something urgent, but because the universe moves slowly, and the evidence of ancient life is buried under billions of years of red dust. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. We can accept the red planet as a silent neighbor, a place of potential and of history. As we look at these 4 worlds together, we see a pattern of density and proximity. They are the inner circle because they are the only ones capable of surviving so close to the sun's fire. They are the anchors of our reality. They are the rocky foundation upon which the rest of the solar system is built. Think about the space between these worlds. Even in the crowded inner circle, the distances are immense. If you were standing on Mars, looking back at Earth, our home would look like a bright blue star, indistinguishable from the other lights in the sky to the untrained eye. The void is already beginning to assert itself. The sun, while still the dominant force, is beginning to look smaller as we prepare to cross the Great Divide. The inner circle is a place of activity of volcanoes, of atmospheres, of shifting plates and crashing asteroids. But as we move outward, this activity begins to cool. The energy of the sun begins to stretch thin. We are entering a phase of the journey where the stuff of the universe becomes less solid and more ethereal. You can feel the transition in the rhythm of your own thoughts. The concrete world of rock and metal is behind us. The familiar landscapes of craters and canyons are fading. We are moving toward a region where gravity is the only thing that remains constant. The inner planets have provided us with a safe, solid beginning, but the true scale of the solar system is found in the gaps that lie ahead. With that in mind, let's move outward once more, to an even larger scale, beyond the reach of the rocky worlds, toward the great debris field that separates the inner system from the giants, toward the silence of the belt and the immense gas-shrouded worlds that wait in the cold. We are leaving the hearth. We are moving into the halls of the kings. This transition is not merely a change in distance, but a change in the very texture of reality. We are crossing a threshold where the sun's warmth becomes a memory, and the density of matter begins to dissolve into the ethereal. As we drift away from the red dust of Mars, the landscape of our solar system undergoes a radical transformation. Behind us, the 4 terrestrial planets are huddled like embers in a fireplace. Ahead of us lies the asteroid belt, a vast, ring-shaped region that serves as the cosmic border between the inner and outer systems. People often imagine this belt as a chaotic obstacle course of tumbling boulders, but to understand its true scale, we must return to our state of patient observation. Imagine the distance between Mars and Jupiter. It is a gap wider than the entire distance from the Sun to Mars. In this immense no man's land, there are millions of fragments of rock and ice, ranging from the size of a dust mote to the size of a dwarf planet like Ceres. But despite there being millions of these objects, the space they inhabit is so vast that the belt is almost entirely empty. If you were standing on a typical asteroid, the next nearest one would be an average of 600,000 miles away. That is more than twice the distance from the Earth to the Moon. You would be standing in a profound, uninterrupted solitude, looking out at a sky where your nearest neighbor is just a tiny, unmoving pinprick of light. Scientists understand the asteroid belt not as a failed planet, but as a collection of building blocks that were never allowed to come together. The immense gravitational influence of Jupiter, the giant that looms just beyond the belt, acted like a cosmic spoon, stirring the debris and preventing it from coalescing into a single world. This challenges how we think about missing pieces of the universe. Sometimes the universe doesn't complete its projects. Sometimes it leaves the raw materials scattered across the dark, a permanent museum of what might have been. What makes this strange is the sheer variety found within this silence. We see Ceres, a spherical world of rock and ice that contains a quarter of the belt's total mass. We see Vesta, a dry, basaltic remnant of a protoplanet. We see metallic asteroids that are essentially floating mountains of iron and nickel. Astronomers didn't expect to find such a diverse chemical library in what was once thought to be a uniform field of rubble. It suggests that the early solar system was a place of violent mixing and migrating orbits, a chaotic birth that eventually settled into the quiet continuity we see today. As we move through the belt, the light of the sun begins to change. It is no longer the golden, life-giving glow of an afternoon on Earth. It is becoming cooler, whiter, and more distant. We are crossing the frost line, the invisible boundary beyond which volatile compounds like water, ammonia, and methane can condense into solid ice. Inside this line, the sun's heat kept these materials in a gaseous state, blowing them toward the outer reaches. Outside this line, the universe begins to build with ice. This transition is the reason for the great divide in planetary size. Once we pass the frost line, the stuff available to build planets changes from scarce rock to abundant ice and gas. It is as if we have moved from a small village built of stone to a sprawling metropolis built of clouds. The scale of what lies ahead is so much larger than what we have left behind that it requires a second mental reset. The inner planets are merely the preamble. The gas giants are the main body of the work. Over immense periods of time, these outer worlds have gathered up the lion's share of the solar system's heritage. To understand this, we must look at the way gravity behaves at this distance. In the inner system, gravity is a sharp, local force. Out here, it is a broad, sweeping power. We are approaching Jupiter, a world so massive that it doesn't just have moons. It has a family of 79 confirmed satellites, a miniature solar system in its own right. But even as we approach these giants, the most striking feature remains the distance. Between the outer edge of the asteroid belt and the beginning of Jupiter's atmosphere, there is a gap of nearly 300 million miles. Think back to our grain of salt, 15 yards from the grapefruit. By the time we reach the inner edge of Jupiter's territory, we have walked nearly 80 yards. The gaps are now larger than the entire inner solar system combined. This brings us to a state of cosmic acceptance. We realize that the order of the solar system is not one of crowded proximity, but of vast, measured isolation. Each world is a lonely sovereign, ruling over a territory of darkness that is millions of miles deep. The halls of the kings are not narrow corridors, but cavernous, silent spaces where the light of the sun is a precious, diminishing resource. Scientists understand the gas giants by listening to the radio waves they emit, deep, haunting groans caused by their massive magnetic fields interacting with the solar wind. What we know so far suggests that these worlds are essentially unfinished stars. If Jupiter had been 80 times more massive, it might have ignited, giving our system a second sun. Instead, it remains a cold, swirling masterpiece of fluid dynamics, a world where the weather lasts for centuries and the surface is a transition from gas to liquid that has no clear boundary. And for now, that ambiguity is simply part of the picture. We don't need a solid ground to stand on to appreciate the scale. We can drift in the upper layers of these atmospheres, feeling the immense pressure of the scale above us and the vast emptiness of the scale around us. The inner circle was about the solid and the certain. The outer system is about the immense and the fluid. As you allow your mind to settle into this deeper, colder region, notice how the rhythm of the journey has slowed. The inner planets moved fast, their years measured in months. Out here, the pace is more deliberate. Saturn takes nearly 30 years to complete a single circuit. Uranus takes 84. Neptune takes over 160. We have entered the realm of long time, where the movements of the heavens are measured in human generations. There is a gentle humility in this realization. We are travelers in a system that does not operate on our schedule. The solar system is a clock that ticks in centuries, not seconds. As we move further into the halls of the kings, let the weight of your own timeline lift. You are stepping into a continuity that is ancient, silent, and incredibly vast. The rocky world you left behind is now just a bright spark in the distance, a grain of salt lost in a quarter-mile field. With that in mind, let's move outward once more, to an even larger scale. Beyond the giants, toward the blue shadows of the ice worlds and the final frozen fragments of the sun's reach, we are leaving the gas shroud behind. We are moving toward the true edge of the light. Now, Let's slowly expand outward. Beyond the orbit of Mars, the character of our solar system begins to change. We enter the asteroid belt. In movies, this is often shown as a crowded field of tumbling rocks, where a pilot must dodge and weave to survive. But the reality is much more peaceful and much emptier. To understand this region, we have to let go of the idea of stuff and embrace the idea of room. The asteroid belt is the first great transition zone of our system, a vast, silent clearing that separates the warm, rocky inner planets from the cold, gaseous giants that loom further out in the dark. If you were standing on an asteroid in the middle of the belt, you likely wouldn't see another asteroid with your naked eye. They are millions of miles apart. The belt is not a wall of stone. It is a vast, sparse desert where the occasional mountain-sized rock drifts in a slow, lonely circle around the sunday. There are millions of these objects, yet they represent less than 1% of the mass of our moon. This is the Great Divide, and it serves as a reminder that the solar system is not a crowded place. It is a series of lonely islands separated by oceans of nothingness. Imagine you are on a journey across this divide. You have left the red, dusty horizon of Mars behind. As you move forward, the sun begins to shrink. It is no longer a dominant, heat-giving disk. It is becoming a brilliant, piercing light, shedding its warmth but keeping its hold on you. In this region, between the orbit of Mars and the orbit of Jupiter, we find the rubble of the solar system. These are the fragments of a story that never quite finished. Scientists understand the asteroid belt not as the remnants of a destroyed planet, but as the raw materials of a planet that was never allowed to form. The gravity of Jupiter, which we will encounter soon, is so immense that it acted like a cosmic stirrer, keeping these rocks moving too fast to ever clump together. What we know so far suggests that if you were to gather every single asteroid in the belt, every grain of dust, and every mountain of iron, and smash them together into one sphere, it would be smaller than our own moon. It is a vast territory with very little to show for it in terms of mass. But what the belt lacks in mass, it makes up for in mystery. We see objects like Ceres, a dwarf planet that accounts for a third of the entire belt's weight. Ceres is a world of its own, with a crust of ice and perhaps a hidden ocean beneath its surface. Astronomers didn't expect to find a world so complex in the middle of a debris field. It challenges how we think about active worlds. Even here, in the cold divide, there are processes at work that we are only beginning to comprehend. What makes this strange is not what we find, but how quiet it all is. We are used to a world where nature means trees, wind, and movement. But in the Great Divide, nature is the absence of these things. It is the slow, silent drift of a billion-year-old rock. It is the way a shadow falls across a crater that hasn't changed since the dawn of the dinosaurs. This is a place of deep time. Think back to our human-scale anchor. If the distance from the sun to the Earth was the length of a single room, the asteroid belt would be the hallway leading to the rest of the house. It is a transition. It is the space you pass through to get somewhere else. But while you are in the hallway, you can feel the shift in atmosphere. The air, if there were air, would feel thinner. The light would feel sharper. You are leaving the living room of the inner system and moving into the grand, cold galleries of the outer giants. Astronomers often look at the asteroid belt as a time capsule. Because there is no wind or water to erode these rocks, they are exactly as they were 4 billion years ago. They are the fossils of the solar system's birth. When we study them, we are looking at the original building blocks of the Earth. We are looking at our own history, frozen in the vacuum. And for now, that stillness is simply part of the picture. It doesn't need to be filled with action. You can imagine yourself drifting through this belt, passing a mountain of iron that glows faintly in the distant sunlight. You don't need to dodge. You don't need to worry. There is enough room here for everyone. The gaps between the rocks are so wide that you could fly 1,000 spaceships through the belt in a straight line and never hit a single thing. This brings us to a state of calm insignificance. We realize that even the boundaries of our solar system are mostly made of peace. The Great Divide is not a barrier, it is a buffer. It protects the inner worlds from the chaos of the outer system, and it provides a quiet space for the mind to expand. To understand the scale of the divide, we must look at the time it takes to cross it. A probe traveling from Mars to Jupiter takes years to make the trip. For years it sees nothing but the distant stars and the shrinking Sunday. It is a journey through a void that seems to have no end. But eventually, the influence of the inner system fades completely, and a new power begins to take hold. We are approaching the edge of the divide. The rocky fragments are becoming fewer and farther between. When we think about the solar system, we often imagine it in human terms. Distances we can walk, time we can measure in years, objects we can see with our own eyes. We look at a map of the planets, and our brains instinctively try to shrink the cosmos down into something manageable, something that fits on a kitchen table or a classroom poster. But the reality is that the solar system is not a collection of objects. It is a collection of distances. It is an exercise in emptiness, punctuated only occasionally by the smallest specks of matter. To understand where we are, we have to first understand how much where there actually is. Imagine, for a moment, that you are going for a walk. You know the weight of your footsteps on the pavement. You know how long it takes to walk to the end of your street or to the local park. If you walked at a steady, brisk pace for an entire hour, you would cover about 3 miles. In our daily lives, 3 miles is a substantial distance. It is enough to change the scenery, to move from a busy downtown to a quiet suburb. But in the context of the solar system, that hour of walking hasn't even moved you the width of a single hair on the scale of the worlds we are about to discuss. To truly grasp the human scale perspective, we must use an analogy that strips away the confusing billions of miles and replaces them with things you can visualize. Let us use the grapefruit analogy again, but let's walk through it slowly, feeling every step of the journey. Imagine you are standing in the center of a vast, empty salt, flat, level ground, stretching to the horizon in every direction, silent and still. In your hand, you hold a grapefruit. This grapefruit represents the Sunday. It is warm, it is bright, and it represents 99.8% of all the matter in our entire solar system. Everything else, the planets, the moons, the asteroids, and you make up that tiny remaining 0.2%. Now, place that grapefruit on a small pedestal in the center of the salt flat. To find the Earth, you have to start walking. You aren't just stepping back a few feet. You walk past the first planet, Mercury, which is a tiny pinhead just 5 yards away from the grapefruit. You keep walking another 5 yards to find Venus, another pinhead. Finally, you reach a distance of about 15 yards, roughly the length of a large school bus, and you stop. There, on the ground, you place a single grain of salt. This is Earth. this grain of salt is your home. Everything you have ever known, every person you have ever loved, every war ever fought, and every dream ever dreamt has occurred on that tiny, crystalline speck sitting 15 yards away from a grapefruit. The first thing that strikes you in this silence is the space. Look back at the grapefruit. From the perspective of your grain of salt, the grapefruit looks small. It's about the size that the actual sun appears in our sky. But look at the ground between you and the grapefruit. There is nothing there. No cosmic dust clouds, no crowded asteroid fields. Just 15 yards of empty air. If you were an ant standing on that grain of salt, the distance to the grapefruit would seem like an infinite journey. Now, let us continue our walk. We want to find the outer reaches of the neighborhood. To reach Mars, the red pinhead, you walk another 7 yards. You are now 22 yards away from the Sunday. The distance is growing, and the grapefruit is looking smaller now. But we are still in the inner circle. To find the next planet, Jupiter, you have to be prepared for a hike. You leave the inner planets behind and start walking across the salt flat. You walk past the 30-yard mark, the 40-yard mark. You keep going until you are nearly 80 yards away from the grapefruit, almost the entire length of a football field. There, you find a cherry tomato. This is Jupiter, the king of the planets. Even though it is the largest planet, compared to the grapefruit, it is still just a small piece of fruit. And the distance between your grain of salt and this cherry tomato is 65 yards of absolute nothingness. As you stand by the cherry tomato and look back toward the center, the grapefruit is now a small dot in the distance. Your home, the grain of salt, is invisible to the naked eye. You are beginning to feel the true scale. But we aren't finished. To reach Saturn, you have to double your distance again. You walk until you are 140 yards away from the grapefruit. To reach Uranus, you walk to 280 yards. By the time you reach Neptune, the final major planet, you are nearly 450 yards away, more than a quarter of a mile from where you started. Stand there for a moment at the Neptune marker. You are a quarter mile away from a grapefruit. If you look back, you cannot see the grain of salt that is Earth. You can barely see the grapefruit. The solar system that we see on posters as a crowded family of planets is, in reality, a vast, lonely desert where the participants are so small and so far apart that they almost don't exist. This challenges how we think about our place in the world. We feel big, we feel important, but on the scale of the grapefruit and the salt flat, we are essentially a ghost. The silence of this perspective is not meant to make you feel insignificant in a negative way. Rather, it is meant to provide a sense of profound relief. All of the pressures of your daily life, the deadlines, the worries about the future, they all exist on that grain of salt. And that grain of salt is safely tucked away in a corner of a quarter-mile wide field of peace. Scientists understand this scale, not just through distance, but through time. If you wanted to send a message from your grain of salt to the cherry tomato of Jupiter using light, the fastest thing in the universe, it would take about 40 minutes for the message to arrive. If you were Neptune and you wanted to call Earth, you would have to wait 4 hours for your hello to reach home and another 4 hours for the reply. The solar system is a place where even conversation happens in slow motion. What makes this strange is not the distances themselves, but the fact that gravity manages to hold it all together. That grapefruit, all the way back at the center, is pulling on the speck of dust that is Neptune nearly half a mile away, with enough strength to keep it in a perfect, steady circle. It is a delicate, invisible clockwork. As you imagine yourself standing on that salt flat, the sun beginning to set, the grapefruit glowing faintly in the distance, you can feel the air grow still. You are a human-scale observer in a cosmic-scale reality. You are small, yes, but you are the only thing in this quarter-mile radius that is capable of understanding the map. You are the mind that holds the grapefruit and the salt grain together. For now, that understanding is enough. You don't need to walk any further tonight. You can simply stand here, in the quiet of the salt flat, and realize that the scale of the universe is not a wall, but an invitation. It is an invitation to let go of the small things and embrace the vastness. With that in mind, let's move outward once more, to an even larger scale. This is where the human brain begins to feel the first gentle tug of the impossible. We have spent our lives navigating a world where a 5-mile hike is a morning's commitment and a cross-country flight is a significant journey. But as we step away from our grain of salt and our grapefruit, we have to abandon these units of measurement. They no longer serve us. They are like trying to measure the depth of the ocean with a thimble. To move forward, we must change our pace, transitioning from the physical act of walking to the mental act of drifting. Think about the speed of a commercial airliner cruising at 500 miles per hour. At that speed, you can cross an entire continent in an afternoon. It feels fast. You look out the window and see the clouds racing by, the landscape shifting beneath you. But if you were to fly that same plane from our grain of salt toward the sun, you wouldn't arrive for 21 years. You would spend 2 decades in the air, flying day and night, just to reach the nearest star. This realization is the first scale reset. It forces us to acknowledge that the empty space we often ignore is actually the most dominant feature of our environment. As we continue to expand our perspective, we encounter the first major boundary of our planetary neighborhood. In our everyday lives, we are used to boundaries that are clear: a fence, a shoreline, a city limit. In space, boundaries are more like gradients, where the influence of one thing slowly fades as the influence of another begins to take hold. We are moving toward a scale where the gaps between objects are so large that the objects themselves start to feel like accidental interruptions in a much larger story of stillness. Consider the moon, our closest neighbor. In most diagrams, it sits just a few inches away from the Earth. But on our human scale, if the Earth were a basketball, the moon would be a tennis ball located 30 feet away. Think of that empty 30-foot gap. You could fit every other planet in the solar system: Jupiter, Saturn, the ice giants, all of them, side by side, inside that single gap between the Earth and the moon, and you would still have room to spare. This is the lunar gap, and it is our first true lesson in cosmic density. We live in a universe that is incredibly efficient at being empty. As we drift further, the numbers begin to lose their edges. We talk about millions of miles, but the human mind treats a million the same way it treats a billion as a lot. To stay grounded, we must return to the feeling of time. Imagine a clock that ticks only once every century. On the scale we are entering, that clock would seem to be moving quite fast. The solar system operates on a rhythm that ignores the frantic pace of human history. The mountains on our grain of salt rise and fall in the time it takes for the outer planets to make just a few laps around the Sunday. Scientists understand this slow-motion reality by looking at the human-scale anchors that still exist within it. We look at the light that reaches us from the Sunday. That light, traveling at 186,000 miles per second, takes 8 minutes to cross the 15 yards of our salt-flat model. When you step outside and feel the warmth of the sun on your skin, you are feeling energy that left its source 8 minutes ago. You are always living in the past, seeing the sun not as it is now, but as it was when you were perhaps just starting a conversation or finishing a cup of tea. This delay is a constant reminder that distance and time are woven together. What makes this strange is not that the universe is big, but that it is so sparsely populated. We are used to a world of constant stimulation noises, lights, people, traffic, but as we expand to the scale of the inner solar system, the stimulation drops to nearly zero. If you were floating in the space between Earth and Mars, there would be no sound, there would be no wind, there would be no sense of movement, even if you were traveling at thousands of miles per hour. Without a nearby object to provide context, speed becomes an abstract concept. You are simply there, suspended in a vast, dark cathedral of light. Astronomers didn't expect the vacuum to be quite so profound until they began sending probes across these distances. They found that space isn't just empty. It is a vacuum more perfect than anything we can create in a laboratory. It is a place of total preservation. A footprint on the moon stays there for millions of years because there is no weather to wash it away. The scale of the solar system is also a scale of permanence. On Earth, we are used to things breaking, rusting, and fading. In the vastness between the worlds, things simply endure. And for now, that endurance is simply part of the picture. It provides a sense of stability. As you continue to drift in your mind, let the vastness of these gaps act as a blanket. There is so much room in the universe for everything to simply be. There is no crowding here. There is no rush. Every planet has its own vast territory, millions of miles of private space in which to perform its slow, ancient dance. We often feel the need to fill silence with words or empty spaces with objects. But the solar system teaches us the value of the void. The void is not a lack of something. It is a thing in itself. It is the stage upon which the planets play. It is the dark velvet that makes the stars shine. By embracing the human-scale perspective of this emptiness, we can begin to let go of our own need to constantly be doing. We can transition from being actors to being observers. To understand the scale of the outer system, we need to step back even further. If our quarter-mile salt flat represented the distance to Neptune, the distance to the next nearest star, Proxima Centauri, would be another 2,000 miles away. Imagine that. You have a grapefruit in one city, and the next grapefruit isn't in the next neighborhood or the next town. It's on the other side of the continent, and in between, nothing. Just thousands of miles of empty salt flats, with the occasional grain of salt or cherry tomato drifting in the dark. This challenges how we think about the neighborhood of our Sunday. We aren't just in a large space, we are in a staggering isolation. But this isolation is what makes our small grain of salt so remarkable. In a continent of empty flats, a single grain of salt that holds life, water, and consciousness is a miracle of the highest order. The scale doesn't diminish us, it highlights us. It provides the contrast necessary to see how special the stuff of the universe really is. As we move toward the next phase of our journey, allow your breathing to slow down, matching the rhythm of the planets. You are no longer walking, you are no longer flying, you are simply expanding. The boundaries of your room have faded, the boundaries of your city have disappeared. You are now as large as the orbit of the Earth, circling the Sun in a slow, silent loop that takes an entire year to complete. There is no tension in this movement. It is the natural state of things. Everything in the solar system is falling, but it is falling in a way that perfectly balances its forward motion, creating the eternal circle of the orbit. It is a state of perpetual grace. You can feel that same balance in your own rest. You are supported. You are in motion, even when you are still. You are part of the clockwork. With that in mind, let's move outward once more, to an even larger scale, where the rocky worlds end and the giants begin. Where the light grows dim and the silence grows even deeper, we are leaving the inner circle, the warm hearth of the sun, and moving into the great, cool expanses of the outer dark. But do not worry. The scale will continue to guide us. The distances will continue to protect us, and the stillness will be our companion. Now let's slowly expand outward. One level beyond what we just explored lies the neighborhood of the inner planets: Mercury, Venus, Earth, and Mars. In the grand design of the cosmos, these are the rocky worlds. They are solid. They have surfaces you could, in theory, stand upon. They represent the high-density center of the sun's domain, a place where the gravity of our star is so intense that it has cleared away the lighter gases, leaving behind only the heavy elements, the iron, the silicate, and the nickel, to form these 4 small, resilient spheres. To understand the inner circle, we must first look at Mercury. It is the closest to the flame. If our sun is the center of a cosmic hearth, Mercury is the stone sitting directly in the embers. It is a world that has been stripped down to its essentials. It has no atmosphere to speak of, no clouds to shield it from the sun's relentless gaze. Because it lacks an atmosphere to trap heat, it experiences the most dramatic temperature swings in the solar system. By day, the surface is hot enough to melt lead. By night, it plunges into a frozen darkness more bitter than any winter on Earth. Scientists understand Mercury by observing the way it interacts with the sun's magnetic field. It is essentially a giant ball of iron, a planetary core that seems to have lost its outer layers in some ancient, forgotten collision. It orbits the sun with a strange, wobbling rhythm, completing 3 rotations for every 2 revolutions. It is a world that refuses to be tidally locked, yet it is forever bound to its master. This delay is the first layer of the deep drift. It is a reminder that the universe has a built-in latency. We are always looking at the past. The further we look, the deeper into history we descend. This challenges how we think about the present moment. Is there even such a thing as now for the entire universe? Plus, or is now just a local experience, limited by the speed at which information can travel? Scientists have spent centuries debating this, and yet the mystery remains as calm and quiet as the stars themselves. Consider the Voyager spacecraft, the furthest human-made object. It has been traveling for decades, moving faster than any bullet ever fired. Yet, if we were to send a light signal to Voyager today, it would reach the craft in less than a day. Light covers in hours what it takes our best technology half a century to achieve. This is the scale of the marathon light is running. It is a constant, tireless sprint across a stadium that has no walls. But even with everything we've learned, there are still things we don't fully understand. We don't know why light moves at this specific speed. Why 300,000 kilometers per second? Why not more? Why not less? It is one of the fundamental constants of nature, a number woven into the fabric of space-time itself. It doesn't need to be explained or justified. It simply is. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. As we settle into this scale, let your mind rest on the idea of the light second. It is a distance of 300,000 kilometers, nearly 10 times the circumference of the Earth. It is a massive distance, yet it is only 1/62nd of a light minute, and a light minute is but a tiny fraction of a light year. We are building a tower of scale, and the light second is just the foundation. Imagine you are a traveler made of light. You leave the Earth behind. In 1 second, you have passed the moon. In 2 minutes, you are passing the inner planets. In 8 minutes, you reach the Sunday. 12. You are moving so fast that the planets appear like stationary marbles in a vast, dark room. But as you look ahead, you realize the room is much larger than you thought. The next nearest object is not minutes away. It is not hours away. It is years away. This is where the true scale of the light year begins to reveal itself. To cover the distance of 1 light year, you would have to maintain this 300,000 kilometer per second pace for 31,536,000 seconds. Every second, another 300,000 kilometers. Every hour, another billion kilometers. Day after day, month after month, for an entire year. By the end of that journey, you would have traveled nearly 9.5 trillion kilometers. That is 1 light year. If we tried to use kilometers to describe the distance to the nearest star, we would be talking about 40 trillion kilometers. The numbers become a noise, a static that our brains cannot process. But 4.2 light years is something we can hold. It is a duration. It is the length of a high school education. It is the time it takes for a toddler to become a student. It gives the distance a human heartbeat. As you drift closer to sleep, imagine these beams of light crossing the void. They are silent. They do not carry heat across the vacuum. They are just pure information, pure energy, traveling through a cold, dark expanse that is mostly empty. The universe is not a crowded place. It is a series of very small lights, separated by very large silences. The light year is the measurement of that silence. We are moving outward now, leaving the realm of the light second and the light minute. We are entering the space where the light year becomes the only sensible way to speak. It is a transition that feels inevitable, like the slow turning of the tide. You don't need to do anything. You don't need to solve any equations. Just let the speed of light become the background rhythm of your thoughts. The universe moves slowly over immense spans of time, even when it is moving at the speed of light. And for now, that uncertainty, that vastness, is simply part of the picture. It is a safe place to be. You are here, in your bed, while the light is out there, doing the work of bridging the distances for you. With that in mind, let's move outward once more, to an even larger scale. beyond the speed of light, beyond the inner solar system, and toward the gaps that define our place in the galaxy. We are now entering the territory where the human-scale anchor no longer just slips, it vanishes entirely. To understand the transition from the speed of light to the distance of a light year, we have to look at the sheer, overwhelming volume of the vacuum. Imagine for a moment that we could drain the universe of all its stars, all its planets, and all its dust. What remains is the canvas upon which light performs its marathon. This canvas is so vast that even at 300,000 kilometers per second, light is not a flash. It is a slow, steady pulse, a lonely traveler crossing a desert that has no markers. As we drift further from the sun, we begin to encounter the true nothingness that defines the cosmos. In our daily lives, empty usually means a room without furniture or a glass without water. But in the space between the stars, empty is a profound, almost mathematical purity. There are regions of space where you could travel for a light year, 9.5 trillion kilometers, and encounter fewer atoms than you would find in a single grain of sand. This is the low-density reality that light must navigate. When we say that a star is 4 light-years away, we aren't just saying it's far. We are saying there is a 4-year-long gap of absolute, freezing silence between us and that distant fire. Scientists understand this by calculating the look-back time. This is a concept that acts as a verbal dissolve between the present and the past. Because light has a fixed speed, every distance in the universe is also a measurement of history. If you look at an object that is 1 light year away, you are seeing it exactly as it appeared 365 days ago. You are not looking across space so much as you are looking through time. This challenges how we think about the reality of the now. In the deep drift of the galaxy, there is no simultaneous moment. Each star exists in its own bubble of time, sending out messages that will not be received for years, decades, or centuries. Consider the sheer scale of a single light year once more. To visualize 9.5 trillion kilometers, imagine the distance from the Earth to the Sun, that 8-minute journey we discussed earlier. Now, take that distance and stack it end to end, 63,000 times. That is 1 light year. It is a distance so long that if you were to represent the Earth-Sun distance as 1 inch, a single light year would still be over a mile long. And remember, the nearest star is over 4 of those miles away. This is the scale expansion that begins to blow the human mind. We aren't just moving away from home, we are moving into a geography that refuses to be tamed by our standard maps. What makes this strange is not what we see, but what we don't understand about the nature of the vacuum itself. Astronomers didn't expect to find that space is expanding, a discovery that adds a layer of quiet complexity to our journey. As light travels its 9.5 trillion kilometers every year, the space it is traveling through is itself stretching, very slightly, every second. It's as if the marathon track is growing longer while the runner is mid-stride. This doesn't affect our local neighborhood much, but over the immense periods of time that light spends in transit, it changes the very color and energy of the light itself. It is a slow, rhythmic stretching of reality that happens without hurry and without end. As you listen, let the rhythm of these numbers settle into your breathing. Ow, 300,000 kilometers per second. 18 million kilometers per minute. 1 billion kilometers per hour. These are not numbers to be feared or solved. They are simply the heartbeat of the vacuum. They represent the tireless work of the universe, moving energy from one place to another across the dark. You are safe in the knowledge that this process is constant. The speed of light does not falter. It does not tire. It is the one thing in the universe that remains exactly the same, no matter where you are or how fast you are moving. And for now, that uncertainty about why the universe is so large and why we are separated by such vast gulfs of time is simply part of the picture. It doesn't need to be resolved tonight. We can accept the silence of the light years. We can accept that the stars we see tonight are ghosts of their past selves, and that our own light is currently traveling outward, a faint signal crossing the void to reach eyes that won't exist for another million years. This is the cosmic continuity, the realization that we are all part of a single, slow-moving story. Imagine you are a photon that has just finished its first year of travel. You have covered 1 light year. You look back, and the sun is no longer a blinding disk. It has shrunk to a bright, steady point of light, one star among many. You look forward, and the destination still looks impossibly far away. There is no wind in space, no sound, and no resistance. You are simply falling through the dark at the maximum possible speed, a tiny spark of information in a cathedral of shadow. This is the essence of the scale loop. We expand our view, we realize the vastness, we accept the mystery, and then we move outward once more. To understand that, we need to step back and look at the human scale perspective one last time before it disappears completely. On Earth, we think of a year as a long time. It is a cycle of seasons, a series of memories. But to the universe, a year is just the time it takes for light to cross a tiny fraction of a galaxy. When we combine the two, the human year and the cosmic speed, we get the light year. It is our way of speaking the universe's language using our own alphabet. It is a gentle humility, acknowledging that while we may be small, we have found a way to measure the infinite. As we conclude this first scale loop, let the image of the light marathon carry you toward a deeper state of relaxation. The light is moving, but you are still. The universe is vast, but you are warm and safe. The distances are mind-blowing, but they are also orderly and predictable. There is a peace in the precision of the speed of light. It is the ultimate clock, ticking away the seconds across the trillions of kilometers. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. We have reached the first marker on our journey. We have looked at the speed, we have looked at the distance, and we have accepted the delay. We are now ready to leave the inner solar system behind for good and look at the objects that wait for us in the deep, quiet dark of the interstellar gaps. With that in mind, let's move outward once more, to an even larger scale. Now, let's slowly expand outward. One level beyond the speed of light lies our own neighborhood, the solar system. To truly grasp the weight of a light year, we must first look at the smaller, more intimate delays that happen right here in our own backyard. We often think of our solar system as a single, cohesive unit, a family of planets huddling around a central fire. But even within this family, the distances are so great that light, the fastest messenger in existence, begins to show the first signs of its struggle against the void. This is where we first encounter the lag of reality, a gentle reminder that nothing in the universe happens in a true, synchronized now. What we know so far suggests that the moon is about 384,000 kilometers away. To our human-scale perspective, this is a massive distance, a journey that took the Apollo astronauts 3 days of intense travel to complete. But for light, this gap is merely a brief pause. When you look up at the moon tonight, you are seeing it as it was 1.3 seconds ago. It takes that long for the sunlight bouncing off the lunar surface to reach your eyes. This is the lunar delay. It is a small, almost imperceptible gap, but it is the first crack in the illusion of an instantaneous universe. If a large boulder were to roll across the lunar plains, or if a meteorite were to strike the surface, you would remain unaware of it for over a second. You are always watching a slightly delayed broadcast of our nearest neighbor. As we move past the moon, the seconds begin to turn into minutes. The sun, the very engine of our lives, sits much further away, about 150 million kilometers. This is the distance astronomers call an astronomical unit, or 1 AU. It is the gold standard for measuring our local neighborhood. Yet, even light needs time to cross this threshold. It takes 8 minutes and 20 seconds for a photon to travel from the surface of the sun to the Earth. If the sun were to suddenly go out, we wouldn't know it for 8 minutes. We would continue to live in its warmth and light, unaware that its source was already gone. Children would keep playing in the park, solar panels would continue to generate power, and the world would remain bright, all while the sun itself was already dark. We would continue to orbit a ghost of a star for those final 8 minutes. This comparison isn't perfect, but it gives us a calm place to begin. It shows us that even the most fundamental things in our lives, the very light of day, are subject to the patient laws of cosmic distance. Scientists understand these delays by observing the movement of the planets. When we send rovers to Mars, for instance, we cannot drive them in real time with a joystick. Depending on where Mars and Earth are in their orbits, the light delay can be anywhere from 3 to 22 minutes. If a rover is heading toward a cliff, the signal telling it to stop takes minutes to arrive, and the confirmation that it has stopped takes another few minutes to return. We are forced to communicate with the solar system through a veil of time. We are always talking to the past version of the planets, and they are always responding to a past version of us. But even with everything we've learned, there are still things we don't fully understand about how these distances affect our perception. Not because we're missing something urgent, but because the universe moves slowly over immense spans of time. To understand the scale, imagine you are standing in a vast, dark forest. You have a friend standing a few hundred yards away with a bell. When they ring the bell, you hear the sound a moment later because sound travels slowly. In the solar system, light is like that bell. It is incredibly fast, but the forest is so big that the sound of the light still takes time to reach your ears. As we drift further out to the gas giants like Jupiter and Saturn, the minutes turn into hours. When we look at Jupiter, we are seeing it as it was 40 minutes ago. When we look at Saturn, the light has been traveling for over an hour. If you were to watch the beautiful rings of Saturn through a telescope, you are seeing them not as they are in this moment, but as they were while you were perhaps finishing your dinner or starting this very script. The universe is a series of nested time capsules, each one holding a slightly older version of reality. This brings us to a quiet realization. We are never truly in the present when we look at the sky. We are observers of history. The light minutes that separate us from the planets are the first steps toward the light years that separate us from the stars. It is a gradual expansion of the now until it becomes so thin that it disappears entirely. In our daily lives, we measure time in seconds, minutes, and hours. But in the solar system, we begin to see that time and distance are the same thing. 1 AU is not just 150 million kilometers, it is also 8 light minutes. The distance is the time. Astronomers didn't expect the solar system to feel so empty, yet the gaps between the planets are far larger than the planets themselves. If you were to shrink the sun to the size of a grapefruit, the Earth would be a tiny grain of sand about 50 feet away. Jupiter would be a cherry about 2 blocks away, and the nearest star, that grapefruit, would be thousands of miles away. This is why we need the light year. Kilometers are too small to bridge the gaps between the fruits in our cosmic orchard. When we think about distance, we often imagine it in human terms. Distances we can walk, time we can measure in years, objects we can see with our own eyes. Our brains are beautifully adapted for the world we inhabit, a world of rolling hills, city blocks, and horizons that seem far away but are actually quite intimate. When you plan a trip to see a friend in another town, you think of it in hours spent in a car. When you go for a morning stroll, you think of it in the rhythm of your footsteps and the gentle passage of minutes. This is our anchor. It is a safe, predictable way of measuring the reality around us. For example, consider the simple act of walking. A kilometer is a distance most of us can visualize clearly. It is roughly 10 to 12 minutes of steady movement. If you were to set out on a walk today and continue until the sunset, you might cover 30 or 40 kilometers. You would feel that distance in your muscles. You would see the landscape change slowly from one neighborhood to the next. This is a scale that makes sense. It is tangible. If you were to walk across an entire continent, it would take you months of dedicated effort, a journey that would define a significant portion of your year. But as we begin to look upward, these human measurements start to feel a bit like trying to measure the depth of the ocean with a teaspoon. To understand a light year, we first have to realize just how much room there is in our own immediate surroundings. Let's look at our own world, the Earth. It is approximately 12,700 kilometers in diameter. To us, that is massive. It contains every ocean, every mountain range, and every city ever built. If you were to get into a commercial airplane and fly non-stop around the equator, it would take you about 2 full days of constant travel. That feels like a long time. It is a distance that commands respect in our minds. Yet, compared to the distances we are about to discuss, the Earth is effectively a single point. Even the gap between us and our closest neighbor, the Moon, begins to strain our human-scale perspective. The Moon is about 384,000 kilometers away. That is roughly 30 Earths laid side by side. If you could somehow drive a car to the Moon at highway speeds, it would take you about 6 months of driving 24 hours a day without a single stop for gas or rest. 6 months. That is half a year of your life spent just crossing the empty space between us and the nearest object in the sky. This comparison isn't perfect, but it gives us a calm place to begin. It reminds us that even near things in space are incredibly far by human standards. And yet, light crosses that same 384,000 kilometer gap in just over 1 second. 1 second. In the time it takes you to draw a single breath, A beam of light has already completed the journey that would take you half a year to drive. This is the first hint of the staggering efficiency of light, and the first clue as to why we need a new way to measure the universe. As we sit here, grounded and safe, we can begin to appreciate the stillness of our own scale. We live in the realm of centimeters, meters, and kilometers. We live in the world of the now, where we assume that when we see something, it is happening exactly as we perceive it. If a friend waves at you from across the street, you see them instantly. There is no lag, no delay that our senses can detect. But as we step further out, we will find that the universe has a speed limit, and that limit creates a bridge between distance and time. Imagine for a moment a vast, empty field. If you stand on one side and a friend stands on the other, and you both hold powerful flashlights, the light from their lamp seems to hit your eyes the exact moment they click the switch. On this scale, light is effectively infinite. It moves so fast, 300,000 kilometers per second, that it feels like a magical, instantaneous presence. Our ancestors, looking up at the stars, likely felt the same way. To them, the stars were just lights on a dome, distant but present, shining their light upon the earth without any sense of travel time. But the reality is more patient. The universe is more deliberate. To understand the light year, we must accept that every piece of light we see is a traveler that has survived a long, lonely journey. Even the light from the sun, which warms your skin on a summer afternoon, is a traveler. The sun is 150 million kilometers away. That is a distance so large that the highway driving analogy breaks down. It would take you 150 years to drive there. You would be born, live your entire life, and pass away behind the wheel before you even made it halfway. And yet, for light, this journey takes only 8 minutes and 20 seconds. When you look at the sun safely, through a filter or at sunset, you are not seeing it as it is now. You are seeing it as it was 8 minutes ago. If the sun were to vanish this very instant, we would continue to feel its warmth and see its light for nearly 9 minutes, blissfully unaware of the change. We are always living in the recent past of the stars. This realization is our first step toward letting go of our human scale perspective. We are moving from a world where everything is here and now to a universe where here is separated by vast thens. It is a shift from the concrete to the expansive. But do not let this make you feel small in a way that is cold or frightening. Instead, see it as a form of cosmic grace. The universe is so large that it allows us to see into the past simply by looking up. It provides us with a history book written in photons. As we prepare to leave the human scale behind and enter the first of our scale loops, take a moment to appreciate the sturdiness of your surroundings, your chair, the walls, the gentle rhythm of your breathing. These are your anchors. They are the zero on our cosmic ruler. From this safe, quiet vantage point, we are going to slowly extend that ruler, 1 light second, 1 light minute, and eventually 1 light year at a time. There is no rush to get there. The stars have been waiting for billions of years. They can wait a few more hours for us to arrive. For now, just hold on to the image of that single beam of light, leaving the sun, traveling through the cold dark for 8 minutes, and finally reaching the earth to illuminate a single leaf or a single window. It is a long way to go for such a small thing, but the universe is full of such journeys. With that in mind, let's move outward once more, to an even larger scale. We are leaving the comfort of the minutes and hours we know, and entering the realm where light begins its true marathon. To understand why we must abandon the kilometer and the mile, we have to look at the sheer inadequacy of our everyday numbers when applied to the celestial void. If we were to stay within our human scale perspective, the numbers would soon become so long that they would lose all meaning, becoming a mere blur of zeros that the mind instinctively ignores. This is why the light year exists, not just as a unit of measurement, but as a bridge for our imagination. Consider, for a moment, the distance across our own planet once more. If you were to take a standard ruler and try to measure the distance from New York to Tokyo, you could technically do it. The number would be in the millions of centimeters, perhaps, but it would be a number you could still write down on a piece of paper. But as soon as we point that ruler toward the sky, the scale shifts in a way that is almost humorous in its disproportion. Our world, with all its vast oceans and towering peaks, is effectively a grain of sand in a desert that has no end in sight. When we speak of human scale perspective, we are also speaking of human scale time. We measure our lives in decades. We measure our history in centuries. To us, 1,000 years is an unimaginably long time, 10 times the length of a long human life. It is the span of empires. Yet, in the context of the distances light must travel, 1,000 years is barely a heartbeat. To understand the light year, we have to marry these two concepts, the distance light covers and the time it takes to do it. It is a measurement that forces us to realize that looking out is the same as looking back. If you were to stand on a hill and look at a mountain range 50 kilometers away, you are seeing those mountains as they were a tiny fraction of a second ago. The delay is so small, roughly 0.00016 seconds, that your brain treats it as instantaneous. This is the comfort of the human scale. Everything we see is now, but as we move outward, this now begins to stretch and tear. By the time we reach the edge of our solar system, the now has become hours. By the time we reach the nearest stars, the now has become years. This is the human scale anchor slipping away, allowing us to drift into the deep drift phase of cosmic understanding. Imagine you are standing in a perfectly dark, quiet room. In the center of the room is a single candle. The light from that candle reaches the walls almost immediately. Now, imagine that room expanding. The walls move back miles, hundreds of miles, millions of miles. The candle remains in the center, a tiny, flickering point of light. If you are standing at the far wall, you have to wait. You have to wait for those tiny particles of light to cross the dark. This wait is the essence of the light year. It is the patience of the universe. In our daily lives, we are used to things being fast or slow. A car is fast compared to a walker. A plane is fast compared to a car. But light is the ultimate speed. It is the speed limit of reality. Nothing can go faster. And yet, even at this ultimate, impossible speed, the universe is so vast that light appears to crawl. To a photon, the trip from one side of a galaxy to another is a marathon that lasts longer than the entire history of the human species. When we use the term light year, we are acknowledging this paradox, that the fastest thing we know is still far too slow to make the universe feel small. Scientists understand this scale because they have to. Without the light year, the maps of the stars would be cluttered with numbers so vast they would be impossible to use in calculations. Imagine trying to describe the distance to a galaxy in inches. The number would have more digits than there are stars in the sky. The light year is our way of simplifying the infinite. It is a human-scale word applied to a non-human reality. It is a way for a creature that lives for 80 years to talk about a universe that has existed for 13 billion. As we settle deeper into this exploration, let the familiar world fade. The roads, the clocks, the schedules of tomorrow, they all belong to the scale of meters and minutes. Here, in the quiet expanse of the script, we are moving into the scale of the light year. This is a place where a short distance is trillions of kilometers. A place where recently means a few centuries ago. It is a safe place to be, because in this vastness, the small pressures of our lives find their proper perspective. They are not erased, but they are framed by a silence that has lasted for eons. Think of the light year as a long, steady breath. It is the distance light travels while the Earth makes one full trip around the Sunday. While you experienced 4 seasons, while you celebrated a birthday, while the trees grew and the snow fell, a beam of light was moving through the void, never stopping, never slowing, covering 9.5 trillion kilometers. It did this while you slept, while you worked, and while you dreamed. Every year of your life, light has added another light year of distance to its journey. This is the perspective we will carry with us as we move into our first scale loops. We will start with the small delays, the seconds and minutes, and gradually build our way up to the years, the centuries, and the millennia. We are not just traveling through space, we are traveling through time. And we are doing it together, safely anchored by the sound of this narrative. There is no need to hurry. The distance is already there, waiting for us to acknowledge it. The human-scale perspective is our starting point, our home base. It is the familiar that we will return to at the very end. But for now, we are going to let the anchor lift. We are going to let the shore of the familiar world recede until it is just a tiny, pale blue dot in the rearview mirror of our imagination. We are moving into the realm of the light year, where the distance truly begins to blow our human minds, not with noise or chaos, but with a quiet, breathtaking vastness. And for now, that uncertainty of how we fit into such a large map is simply part of the picture. It doesn't need to be resolved tonight. We are simply moving outward, step by step, light second by light second, into the beautiful dark ocean of the cosmos. Now, let's slowly expand outward. One level beyond what we just explored lies the speed of light itself. To grasp the distance of a light year, we must first become intimately acquainted with the traveler that defines it. Scientists understand a light year by observing the fastest thing in the universe. Light travels at about 300,000 kilometers every single second. This is a speed that defies our biological wiring. In the time it takes you to blink a mere fraction of a second, a beam of light has already circled the Earth 7.5 times. It is a speed that seems instantaneous to our human senses, yet in the grand architecture of the cosmos, it is the fundamental yardstick by which all things are measured. When you flip a switch in your home, the room is filled with light immediately. There is no perceived delay between the movement of your hand and the illumination of the walls. For all intents and purposes in our daily lives, light is omnipresent. But as we step away from our atmosphere and into the vacuum, we realize that light is not a state of being. It is a physical entity moving through space. It has a beginning, a middle, and an end to its journey. It is a constant, unwavering pulse that dictates the very rhythm of reality. To visualize this speed, imagine you are standing at the start of a long, straight track that stretches into the horizon. If you were to fire a laser beam down that track, by the time you could even begin to process the flash of the light, that beam would be thousands of kilometers away. If we compare this to our human-scale anchor, the disparity is almost humorous. A commercial jet travels at about 900 kilometers per hour. A beam of light travels at over 1 billion kilometers per hour. If you were to race the two, the jet would appear to be standing perfectly still, frozen in time, while the light vanished into the distance. What makes this strange is not just the speed, but the fact that this is the absolute limit. Astronomers didn't expect to find a universe with a hard speed cap, but nature has provided one. No matter how much energy you use, no matter how powerful your engine, you can never overtake a beam of light. It is the gold standard of the universe. And yet, even at this impossible velocity, the universe is so vast that light often appears to crawl. This is the central paradox of cosmology. The fastest thing we know is still far too slow to make the universe feel small. Imagine a single photon, a tiny packet of energy, leaving the surface of a star. It has no mass, no weight, and it experiences no time. From the photon's perspective, its journey from the center of the galaxy to your eye is instantaneous. But for us, standing on this small blue planet, we must wait. We must wait for years, centuries, or even millennia for that photon to complete its trek across the void. This waiting is what defines our perspective. It is why we cannot talk about distance in space without also talking about time. A light year is the marriage of the two, the distance covered in the time it takes the Earth to orbit the Sun once. As you listen to these words, think about the light in the room again. It feels now, but it is actually a few nanoseconds old. When you look at the person sitting across from you, you are seeing them as they were 1 billionth of a second ago. On Earth, this doesn't matter, but as we move outward, the lag becomes meaningful. If you were to stand on the moon and shine a laser back at Earth, it would take 1.3 seconds to arrive. If you were having a conversation with someone on the moon, there would be a gentle, rhythmic pause between every sentence, a 1.3 second gap that you could never bridge. And so the universe continues, expanding, cooling, changing slowly, quietly, endlessly, endlessly. The rover's mission is a small light in a very large room. You don't need to stay awake for the rest of the story. The moon will continue to turn. The sun will rise over the von Karman crater again in 14 days, and then it will set again. The universe will still be here, moving gently forward, long after this moment passes. And the dust is still, the glass beads are silent, the tracks are permanent. You can let go of the details now. The vacuum of space is not a void, it is a rest. And somewhere within all of this, we can begin again, by starting with something familiar. As we reach the furthest edge of our journey, the specific mission logs and the technical triumphs of the Chang'e 4 mission begin to blend into the larger, unchanging canvas of the cosmos. The rover, Yutu-2, remains where it last stopped, its metal cooling in the long lunar shadow. The The tracks it carved into the von Karman crater are now part of the moon's permanent geography. In an environment without wind, without water, and without the stirrings of life, those thin, parallel lines in the regolith will remain for 1,000,000 years. They are a signature of a moment when humanity reached out to touch the hidden side of its neighbor, but now that signature belongs to the moon itself. It is a quiet, eternal addition to a world that keeps everything and forgets nothing. The vacuum of space, which we often imagine as a cold and hostile emptiness, is actually a state of perfect, undisturbed rest. It is the baseline of the universe, the quiet foundation upon which all stars and galaxies are built. In this vacuum, there is no friction to slow the planets, no noise to disturb the silence, and no rush to reach a destination. The far side of the moon exists within this rest, shielded from the frantic radio waves and the bright lights of our own world. It is a sanctuary of stillness. By allowing your thoughts to drift toward this place, you are inviting that same vacuum-like peace into your own mind. You are clearing away the atmospheric noise of your day, leaving only the steady, silent light of the stars. You don't need to stay awake to watch over the moon. It has looked after itself for 4.5 billion years, and it will continue to do so long after tonight has passed. The translucent glass beads will continue to glint whenever the sun hits them at the correct angle. The gel-like melt rock will remain in its crater, a frozen memory of an ancient impact. The jade rabbit rock will stand its watch on the horizon, indifferent to whether it is seen or celebrated. These things are not waiting for us. They simply are. There is a deep, resonant comfort in knowing that the universe does not require our constant attention to maintain its beauty or its order. It moves according to laws that were written at the beginning of time, laws that are patient, predictable, and profoundly calm. The universe continues its slow, inevitable expansion. Galaxies are drifting apart, making more room for the quiet dark. Stars are burning through their fuel with a steady, unhurried glow, providing the light that the moon reflects back to us. The moon itself is continuing its slow outward spiral, moving a few centimeters further away with every passing year. This is the infinite ending, a conclusion that is never reached, but always unfolding. It is a process of cooling, of softening, and of expanding into a state of total peace. You are a part of this process. Your sleep is a micro-scale reflection of the cosmic drift, a time to cool, to settle, and to expand into the quiet reaches of your own imagination. The details of what China found on the moon are now safe in the archives of history. You can let them go. You don't need to remember the name of the crater or the speed of the rover. All you need is the feeling of the grey dust, the weight of the silence, and the sense of a world that is perfectly content to be hidden. The far side remains our silent partner, a reminder that there is always more to the story than what we can see. It is the guardian of our mysteries, a place where the unknown is not a threat, but a promise of more to discover whenever we are ready to move slowly enough to see it. And so the universe continues, quietly, endlessly, gently. The stars do not hurry. The planets do not rush. The moon does not falter. As you sink deeper into your own rest, imagine the view from the von Karman crater one last time. The Earth is nowhere to be seen. The sky is a thick tapestry of ancient light. The ground is a soft, powdery grey. The silence is total. In this place, There is no yesterday and no tomorrow. There is only the infinite now, the steady presence of the cosmos and the safety of the dark. The universe will still be here when you wake. It will still be moving forward with the same gentle, inevitable pace. The moon will still be in its orbit. The rover will still be in its crater. But for now, none of that requires your concern. You have traveled across the void, seen the secrets of the hidden side, and returned to the safety of your own breath. The journey is complete, and yet, because the universe is a loop of continuity, it is always ready to begin again. The vacuum is a rest, the silence is a home, the dark is a blanket. And somewhere within all of this, in the quietest part of the night, where the scale of the universe and the scale of a human life become one and the same, we can begin again. We can return to the start of the circle. We can look up at the moon, even the side we cannot see, and find ourselves exactly where we were meant to be, starting with something familiar, moving slowly outward, into the quiet, into the dark, into the rest. The universe is patient, the moon is still, and you are, finally, at peace. To understand this infinite return, imagine the moon not as a distant destination, but as a mirror reflecting the absolute stillness that exists within you. As the U2 rover rests in the deep shadow of the von Karman crater, it is not simply waiting for the sun, it is participating in the fundamental state of the cosmos. Most of the universe is not in a state of frantic activity. Most of it is like the far side, cool, silent, and undisturbed. When we align our own rhythm with this cosmic baseline, the boundaries of the day begin to dissolve. The worries that felt so heavy and sharp only a few hours ago become like the dust on the lunar plains, fine, soft, and eventually perfectly still. The cycle of the moon is a loop that has repeated billions of times. The sun rises over the jagged eastern rim, crawls across the black sky for 14 days, and then sinks below the western horizon, ushering in a 2-week night. This is the heartbeat of our neighbor. It is a slow, rhythmic pulse that requires no effort from us. By starting with something familiar, the breath in your lungs, the weight of your body, you can begin to feel that same pulse. You are moving slowly outward, away from the specific details of China's discoveries and into the general truth of the universe's continuity. The glass beads, the gel-like rocks, and the subsurface echoes are all just notes in a song that never truly ends. Think about the permanence of the tracks left by the rover. On Earth, we are used to things being erased. We walk on a beach, and the tide washes away our footprints. We build a city, and eventually, the weather wears it down. But on the far side of the moon, the tracks are a permanent record. They will be there when the next generation of explorers arrives, and the generation after that. This permanence is not a burden, it is a form of safety. It means that nothing is truly lost. The curiosity that sent the rover to the dark side, the wonder we feel when we see the images of the Jade Rabbit rock, these things are etched into the history of the solar system. They are part of the infinite ending, a story that continues to expand without ever needing a final chapter. The vacuum of space is often described as a void, but for the mind seeking rest, it is a vast, open room. It is a place where there is nothing to trip over, nothing to solve, and nothing to fear. In the vacuum, light travels forever without losing its clarity. In the vacuum, the rocks stay cold, and the silence stays deep. By drifting into this rest, you are allowing your own internal vacuum to clear away the clutter of the day. You are finding the dark side of your own consciousness, the quiet, hidden hemisphere where you don't have to perform, where you don't have to be seen, and where you can simply exist. As you lie there, consider the scale of the universe once more. The moon is a small satellite of a small planet, orbiting a medium-sized star in a quiet corner of a vast galaxy. This insignificance is the ultimate comfort. It means that the universe is large enough to hold all of our mistakes, all of our questions, and all of our uncertainties without ever being disturbed. The moon doesn't care if we understand the gel at the bottom of the crater. The stars don't care if we ever solve the mystery of the subsurface echoes. They simply continue to shine, to orbit, and to exist. We can learn from this. We can accept the rock for what it is, and we can accept ourselves for what we are: temporary, curious, and currently very tired. The universe is patient because it has no reason to hurry. It has trillions of years to cool, to expand, and to change. The moon is still because there is nothing to move it, and you are at peace because you have followed the rover's tracks as far as they can go. You have looked at the glass beads and the mystery hut, and you have found that they are all just parts of a single unified landscape. There is no longer a need to distinguish between the human and the cosmic, the desk and the crater, the breath and the void. They are all made of the same stardust, moving in the same direction toward the same quiet end. And so, we return to the beginning of the circle. The images of the far side fade, the technical data disappears, the voice of the narrator becomes just another part of the silence. You are left with the familiar feeling of your own rest, the steady pull of sleep, and the knowledge that the moon is still there, turning its hidden face to the stars. The jade rabbit rock is still sitting on its rim. The U2 rover is still waiting in its shadow. And you are exactly where you were meant to be, drifting into the infinite, safe in the dark and at peace with the unknown. The universe is patient, the moon is still, and you are finally at peace. Good night.